Hello, and welcome to the July edition of AJP-Heart and Circulatory Physiology's Video Table of Contents, or From the Editor's Desk. This month we've published two great review articles, 17 original research articles, including two rapid reports. Two of our calls for papers have recently closed, and we thank you for the great response we received on the calls for papers on exercise and amelioration of cardiovascular disease and on mining the benefits of natural products for cardiovascular benefit. I hope your paper was accepted. So without further ado, let's see what's on the inside. Timely review, Adams et al. Discussed the role of exercise training on several important molecular mechanisms that target the endothelium and skeletal muscle. The type of training is also discussed. This is all put into the clinical context of beneficial effects on cardiovascular disease. This review should be of interest to everyone. Coe and colleagues provide a review of the cardiorenal syndrome in chronic kidney disease. In this review, they discuss a wide variety of factors, such as protein-bound uremic toxins that contribute to vascular remodeling and lead to arterial stiffness, reduced cardiac perfusion, and impaired left ventricular function. This review summarizes current knowledge on how protein-bound uremic toxins influence the vasculature, clarifies the relationship between uremic toxic-bound vascular disease and the cardiorenal syndrome, and highlight the potential therapeutic strategies of uremic vasculopathy in the setting of the cardiorenal syndrome. Khaled and co-workers investigated the mechanisms by which 12-15 lipoxygenase can promote either resolving or non-resolving inflammation. Specifically, the mechanism of how 12-15-LOX interacts with polyunsaturated fatty acids in post-myocardial infarction healing was investigated. The results show that deletion of 12-5-15-LOX and short-term exposure to polyunsaturated fatty acids promoted leukocyte clearance, thereby limiting cardiac remodeling and promoting an effective resolution of inflammation. Weichard et al. Hypothesized that Desmond breakdown is an early and continuous process throughout volume overload. Male Sprague-Dawley rats had aortocaval fistula or sham surgery and were examined 24 hours and 4 and 12 weeks later. Desmond mitochondrial ultrastructure was examined by transmission electron microscopy and immunohistochemistry. Significant increases in protein indicators of mitophagy were countered by a six-fold increase in p62 sequestosome 1, which is indicative of an inability to complete autophagy. An early and continuous disruption of the Desmond mitochondrial architecture accompanied by oxidative stress and inhibition of apoptosis and mitophagy suggests its causal role in LV dilation and systolic dysfunction in volume overload. Et al. Previously demonstrated that ultrasound biomicroscopy, or UBM, is a non-invasive and effective approach for predicting thoracic aortic constriction success. Here they investigated the value of UBM for serial predictions of load conditions in establishing a murine hypertrophic model. The cardiac hypertrophic responses were examined by UBM, by histology, by RT-PCR, and Western blot analysis. They established a UBM protocol for the serial assessment of aortic flow and the prediction of left ventricular end systolic pressure during repeated aortic manipulations in mice, which might be useful for non-invasive evaluations of the murine hypertrophic model. Finally, Coriam et al. Tested the hypothesis that cyclic AMP-activated mechanisms actively restore vascular barrier integrity in post-ischemic striated muscle. They found, using ischemia reperfusion in intact muscles and hypoxia reoxygenation in human microvascular endothelial cells, that hyperpermeability can be deactivated by increasing cyclic AMP levels through application of forskolin. They demonstrated that 1. VEGF microRNA expression is not involved in hyperpermeability after brief ischemia, 2. Elevation of cyclic AMP concentration at reperfusion deactivates hyperpermeability, and 3. That cyclic AMP activates the EPAC-RAP1 pathway to restore normal microvascular permeability. So those are some of the highlights for July. Thank you for watching. I hope those of you in the Northern Hemisphere are getting some rest and relaxation this summer. And to everyone else around the globe, keep following us on Facebook and Twitter, and please send us your best work now.